Okay? And this has been going on for long enough. In fact, this is a bit misleading because Gordon Moore was talking in 1960 and not in 1900. But this diagram is taken from a Ray Kurzweil book. According to Ray Kurzweil, who's become the guru of the singularity subject, Moore's law goes all the way back to at least 1900 because we are not counting necessarily transistors per chip. We can count all sorts of things. We can count tubes. We can count all sorts of computing equipment. You can even go back to Abacus if you want and talk about the performance of computing equipment. And what's interesting is that not only transistors per chip or computing equipment or hard disk speed or whatnot, but all sorts of other things continue to double, like DNA sequencing cost. Okay, DNA sequencing cost has gone from, it took a whole world to produce one, and these days you can just pretty much do it over the mail for I don't know how many hundreds of dollars. Now, the idea of singularity has gained a lot of resistance. One of the people who resist to it most is a futurist who's called Modis. I forget his first name. And Modis, Modis is claiming something which is very, very sensible, and in fact it's true pretty much for almost any model in ecology. And he says, hang on, nothing goes on exponentially forever. And here's the exponent, and that's imaginary. In fact, what happens in reality is that most developments look like exponents at some point, but then they level out. So, most of the time, what happens, whether you count oil production in the US or GDP or whatnot, is that a development goes in an S-curve, not exponentially, going all the way up to the sky. And if you happen to be here, which is where we are supposed to be, it looks like an exponent. It's going to level off very quickly. And there are all sorts of other objections to the singularity that come from all sorts of people, but this is one of the most scholarly ones. So, so there is acceleration, there is incredible growth rate, there's acceleration in technology, and the question is, where is all this leading us? And again, going back to Toffler, he claimed already in 1970, what is occurring now is in all likelihood bigger, deeper, and more important than the Industrial Revolution, nothing less than the second great divide in human history, the shift from barbarism to civilization. So we're alive, according to more people than we realize, in a period where things are going to change irreversibly, irrevocably, and uncomparatively to anything else we ever heard of. Now, what does that mean? Because I haven't said a single word about what's the singularity and what does it mean. The interpretation, which is pretty much not the most popular one. This one, the intelligence explosion, is not the most popular interpretation of the singularity, but it's probably the one which we A, best understand, and B, deserves the word singularity more than anything else, because we're talking about an event, not about a wave, not about the development. Now, it's a bit difficult to understand what does it mean, intelligence explosion, without being an expert in machine intelligence, machine learning, and AI, but luckily I have here, we have here Anders to talk about machine intelligence. And since Anders is so much more knowledgeable and smarter and handsomer than me, I'm not going to talk much about it. But just mention the fact, just give you a brief impression what is the intelligence explosion and why it deserves the word, the term singularity. This description is taken from a mathematician's book which describes exactly how intelligence can suddenly explode. So first of all, it defines what's an ultra-intelligent machine. It's just a machine which is smarter than every one of us. And then it says, let's say you've designed a machine which is as intelligent as you, or just slightly more intelligent than you. Now, if it's as intelligent than you design that machine. If that machine is just the slightest bit more intelligent than you, then that machine can design another machine which is just the slightest bit more intelligent than the first one, and the second one can go on and design yet more intelligent, and yet more intelligent, and yet more intelligent. Now, of course, they're going to get faster and faster because they're so much smarter. They don't need 2 million years to produce intelligence. They just need a brief instant of time. So this is why the term here, in this context, the term singularity might be justified on the grounds of the subject. What is being described by the term is an event, and it possibly can happen within hours. It can be almost instantaneous in historical terms. Okay, Alan Turing. Alan Turing never spoke about intelligence, but Alan Turing, okay, who's Alan Turing? One of the greatest visionaries of all times, the father of computer science. Alan Turing, who saw so much well into the future, pretty clearly said towards the end of his life that once machine thinking method has started, it would take us very long to it would not take long for it to outstrip our feeble powers, and we can even expect the machines to take control. And how will machines take control exactly? I mean, again, I don't have enough time, but the example that Nick Bostrom gives is the Paperclip Factory. And this is a very good example to demonstrate why machines can and may take over without any intention. And this example is the Paperclip Factory example. Imagine a paperclip factory which happens to be just a bit too smart for its own good, or too smart for our own good. Okay? Just a paperclip factory. And just tell it, make as many paperclips for as little money as possible. And what this paperclip factory would end up doing is turning everything around it into paperclips, including us and the whole planet, and the air we breathe and the food we eat. Just because we told it to make paperclips, we didn't tell it, make paperclips and try not to kill me in the process. That's why superintelligence is so dangerous. And just before I finish, the AAAI, the American Association for Artificial Intelligence, was convened into what was called in 2009 the Presidential Panel on Long-Term AI Future in Asilomar. Apparently George Bush felt the ground getting warm, and he wanted scientists to tell him, really, should we be worried about, an intelligence explosion? And they came back and they said, radical views expressed by futurists and science fiction authors, there was overall skepticism about the prospect of intelligence explosion. So the establishment of artificial intelligence academia looks at this idea at best as idiotic. And there are two other interpretations of the singularity, which I'm not going to get into. People here probably know about it a lot more than me. Transhumanism is the idea that we will have the next rung in evolution pretty soon. You could argue that there is not much difference here. And posthumanism is about the emergence of the next. It's concerned with the emergence of the next step in the evolutionary ladder. And one of the least known things people talk about is the emergence of whole brain emulations, but I really run out of time, haven't I? Okay.
Okay, if you've got any final words.
Okay, I just give you a minute about what whole brain emulations are supposed to be. Again, I'm very embarrassed that there is someone here who knows so much more about the underside. Right, what is a whole brain emulation? Machine intelligence created by modeling the computational architecture of the brain. So imagine you take your own brain, yes, you freeze it, vitrify it, slice it, yes, take each slice and build a computer model of it and execute it. So whole brain emulation is interesting because you can have your lawyer and you're a gossip columnist on USB Key. And whenever you need, then imagine what the world would look like if this is going to happen, and apparently it's going to happen, according to some people, a lot sooner than you think. You need a lawyer, you just stick the USB stick, and you get their expert's opinion. That's it.
Thank you.